Welcome to another session of Learning Together, sponsored by the Russie's Roses Foundation. It is our desire, it is our intention that as a result of these tutorials, that you will increase your math skills. Today, our focus will be on simplifying radicals as well as solving radical equations. So whenever you hear the word radical, I remember in the last class, the last session, we were doing completing the square and also the quadratic formula. And we discovered that there are some answers that needed to be reduced further. And because I didn't cover radicals before, I didn't want to complicate the matter, so I kept it for today. So whenever you hear the term radical, it means that you have that expression and something is inside. For example, we have this, and if we have x, this symbol is the radical, and what is inside the radical is called the radicand. So the symbol, the hook, is called the radical, and what is inside is called a radicand, okay? Now, it's important to note that the symbol can be used for different roots. For example, if we had, say, x squared equal to 16, we say we can find x by getting rid of the square symbol, and we use the inverse of square, which is called square root. And that's where we end up with x equal to plus or minus the square root of 16. It is plus as well as the minus, the two signs, because remember, negative 4 times negative 4 will give you 16, and positive 4 times positive 4 will also give you 16. And we also discussed in a previous session that the number of solutions, the number of roots, the number of zeros is dependent on the highest exponent in your equation. So in this case, we have the second degree, or it's a quadratic equation, so we needed two answers. And sure enough, we have positive 4 and negative 4, two answers. Okay? So I should point out to you that if the root is not specified, the automatic understanding is that we're looking for the square root. So if the symbol is not here to show what root it is, we automatically know that it's the square root. So you could actually put a 2 here to show what root it is. But you don't have to put the 2 because it is understood that it's square root. Just as though we didn't have to put a 1 here, but we know that this is actually 1x. Just as though we didn't have to put the exponent here, we know that it's x to the power 1. So there are certain things that are understood and accepted as default or standard. However, if I gave you y to the third equals to 27, in order to get rid of the cube, y to the power 3, we have to find what is called the cube root. Remember, we had the square root, now it's the cube root. So y is going to be equal to, and now you put the 3 here of 27. In other words, what times itself 3 times will give you 27, and we know that 3 would be the answer, because 3 times 3 times 3 is 27. Similarly, if I gave you x to the third equals to 64, we know that x is going to be equal to the cube root of 64, and we know that x is going to be equal to what times itself? 4 times gives you 64. We know 4 times 4 is 16. 4 times 16 is 64. So 4 is the answer. Notice I put the 3 inside the hook, meaning it's the cube root. Okay? Good. Another example, I guess you will see the pattern. If I gave you x to the 5th power equals to 32, then you know that x has to be equal to the 5th root of 32. The 5th root. So now you know you have square root, cube root, 4th root, 5th root, 6th root, whatever root you need. Just put the number right inside the hook, and that specifies what you need. In other words, what times itself 5 times will give you 32, and we know that the answer is 2, because 2 to the 5th power is 32. Okay? So these that we have done so far are very easy. Very easy to find the square root of 9, the square root of 16, the square root of 25. But what happens if you get an expression that is more involved and does not have a perfect square? How do we handle that? In other words, what happens if we're asked, what is the square root of 32? Well, what times itself gives you 32? There isn't a whole number. There isn't an integer times itself that will give you 32. We know that the answer is going to be somewhere between 5 and 6. 5 squared is 25, too small. 6 squared is 36, too big. So it's somewhere in between 5 and 6. But when you get to this level of math, you don't want a decimal. You want to just reduce this to its simplest form. And that's why we call simplifying radicals. So how do you do it? Well, I'm going to share with you 2 methods. One method says, look at the number 32 and think of a perfect square that you could multiply to get 32. And I can say that if you really think hard, you realize that 16 times 2 gives us 32. 2 times 16 is 32. But 16 is a perfect square, so therefore square root of 16 is 4. 4 can come outside, so the final answer is 4 root 2. Many students have difficulty with this concept, but truthfully, it's not a complicated concept once you understand how to do the manipulation. Let's try another one. If I ask you what's the square root of 75, you say, 75. Is there a perfect square that I can multiply to get 75? And the answer is yes. 25 is a perfect square, and 25 times 3 will give you 75. So therefore, we write 25 times 3. And as we look at this, you know the square root of 25 is 5. And 3 remains in the radical. So the square root of 75 is 5 root 3. So that's one method, thinking of a perfect square times a number. Is there another method? And I said before that there are 2 methods, so I show you the other method. Okay? So the numbers we're working with are 32 and 75. We got 32, square root of 32, square root of 75. We got 4 root 2, and we got 5 root 3. So let's use the other method and see if it works. Okay. The other method is very useful. It is what is called a tree diagram. Using what is called a tree diagram. What this involves is breaking down 32 into its prime factors. Prime factors. Prime numbers are numbers that can only be divided by themselves and 1. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Those numbers cannot be divided by any other number other than 1 and themselves. Okay? So how do we break down 32 into its prime factors? Well, let's go. 32 is equal to, start with the lowest prime number possible and then keep building. So it's actually 2 times 16. Try again. It's 2 times 8. Oh, we can do 2 again. 2 times 4. Oh, we can do 2 again. It's 2 times 2. So we discover that 32 is 2 times 2 times 2 times 2 times 2. And what you need now, since we're looking for the square root, we're looking for pairs. What times itself? That's a pair. So that's one pair, and that's another pair, and that is single. So this doesn't have a match, so therefore there is no square root for this. So this is going to stay inside the radical. Out of this, the square root of this is 2. The square root of this is 2. So 2 comes outside, 2 comes outside, and 2 times 2 gives us 4. So here we go. So the square root of 32 becomes the square root of 2 squared times 2 squared times 2. What happens here? This 2 comes out. This 2 comes out. And this stays inside because it's single. So now we have 2 times 2 is 4 root 2. So it's a tree diagram. Now for simple numbers like 32, 75, this might not be big, but when you have larger numbers, the tree diagram becomes extremely useful. Okay? So let's try 75 and see how that works. What did we do? We broke down 32 until we couldn't break it down any further. And then we got our pairs. This is single. So this stays inside. 1 comes out, 1 comes out. 2 times 2 gives us the 4. Let's try 75. $75 is an odd number, so we know we cannot use 2. 2 will not go into 75. What's the next number that we could use? Oh, the next number is 3. 3 into 75 goes 25 times. 3 cannot go into 25, so we're done with that. However, 5 can go into 25. We know it's 5 times 5. So 75 is 3 times 5 times 5. We're looking for the square root, so we need to get all the pairs that we can. In this case, we just have one pair, which is 5 times 5. So when I go for the square root of 75 is equal to the square root of 5 squared times 3. This is a perfect square, so that comes outside. This is not a perfect square, so it stays inside. So we end up with 5 root 3. Same answer as we got before. Okay? Let's try something that's a little bit more involved and see how we get that done. Let's go for the square root of 675. Wow, that's a big number. So when you look at this, it is not something that you could just off the top of your head think of a perfect square and get the answer. So why not just break it down using the tree diagram? Here you go. 675. Can we use 3? 3, yes, 3 will work. So I see 3 into 6 goes 2 times, 3 into 7 goes 2, 3 into 15 goes 5. Let's see again. 3 into 6 goes 2, 3 into 7 goes 2, 3 into 15 goes 5. Can we use 3 again? Yes. 3 into 22 goes 7, 3 into 15 goes 5. Can we use 3 again? Goes 25. Now we have exhausted all the 3's. Now we're down to 5 times 5. So now we need to find out how many pairs do we have. I see one pair here, and I see another one here, and I'm left with a single. So therefore, the square root of 675 is going to be equal to the square root of 3 squared times 5 squared times 3. This 3 is single. This is a pair, that is a pair. So square root of 3 squared is 3, square root of 5 squared is 5. So it's 3 times 5 times the square root of 3 equal to 15 times the square root of 3. So we finally, this is the simplest version of the square root of 675. That's it. Let's do one more for square root and then we'll go to cube root. Okay, what about this one? Oh, that's a massive number, massive number. Can we do it? Let's see. The method remains the same. The process remains the same. We go step by step by step until it's finished. It's an even number, so we can start with 2. That gives me 2. This gives me 1, 7, 6, 4. Let's double check. 2 into 3, 1, 2 into 15, 7, 2 into 12, 6, 2 into 8, 4. It's even, so I can do 2 again. So it's 8, 8, 2. Let's check. 2 into 17 goes 8, 2 into 16 goes 8, 2 into 4 goes 2. I can do 2 again. 44, 1. So this is now odd. I cannot use 2. So let me try 3. 3 into 4, yes, 3 will work. 3 into 4 goes, so it's 3 and 1, 4, 7. Can 3 work again? 3 into this goes, yes, it can. So it's 3 goes 4, 9. And 49, 3 cannot work. However, 7 will. So now let's put all the pieces together. What do we have? We have one pair, we have another pair, we have another pair, and we have a single. So by now you get the gist. It's going to be equal to the square root of 2 squared times 3 squared times 7 squared times 2. Which is equal to 2 times 3 times 7 times the square root of 2 equal to 2, 3, 6, 6 sevens, 42 root 2. So now you know how to reduce the square root of a number, if possible. There it is. The square root of this is 42 root 2. And that's the simplest form. Let's try cube root and see what happens. were asked for the cube root of 32. Cube root of 32. Well, 3 cubed is 27. 4 cubed is 64. This is 32, so it's somewhere between 3 and 4. So here we go. It's 2 times 16, 2 times 8, 2 times 4, 2 times 2. So 32 is 2 times 2 times 2 times 2 times 2. Cube root needs not groups of 2, but groups of 3, because it's cube root. What cubed will give you 32? Looking for groups of 3. So we go 1, 2, 3. So we have 1 triple, and we have these left over. So you can say this is equal to the cube root of 2 cubed times 4. Notice 2 times 2 is 4. What is the cube root of 2 cubed? It's equal to 2 cube root of 4. And that would be your answer. Let's try another one. So the numbers will work. Let me pull something up. Okay. Cube root of 1080. What is that equal to? Well, let's go for 2. We get 5, 4, 0. Let's go for 2. We get 2, 7, 0. Let's go for 2. We end up with 1, 3, 5. 22, 1, 27 is 3, 20 that is 5. What can we use? We can use 3. 3 into 13 goes 4 times, and 5. 3 into this goes 15. 3 into this goes 5. So there it is. Groups of 3, it's cube root, so we need groups of 3. So we have one group here, another group here, and 5 left over right here. There's a 5 left over. So this is equal to the cube root of 2 to the third times 3 to the third times 5. That's what you get from the tree diagram. So we end up with cube root of 2 cubed is 2 times cube root of that is 3. And we end up with cube root of 5. And then, of course, that's gives you 2 times 3 is 6 cube root of 5. And that will be perfectly acceptable. Okay? So now we know how to reduce a radical. Now we're going to do some arithmetic involving radicals. Suppose you were asked to simplify 2 root 3 plus 5 root 2 plus root 3. What's that equal to? 2 root 3 plus 5 root 2 plus root 3. Well, you treat the radical like a variable. And in order for you to add or subtract, you must have the same radical. In other words, this is like 2 apples plus 1 apple. And that's going to give you 3 apples. This is banana. It's a different radical, so you can put it together to count as the same item. It's not the same, it's a different radical. So in this case, 2 root 3 plus 1 root 3 gives us 3 root 3. This doesn't have anything to go with, so it remains the same. That's it. Let's try another one. Six root 5 minus 4 root 2 minus square root of 50. What is that equal to? Well, when you look at it initially, this is root 5, this is root 2, this is root 50. They all look different. However, root 50 seems like it could be reduced. So we could say, okay, so maybe this is 6 root 5 minus 4 root 2 minus, and that gives me 25 times 2, which works out to be 6 root 5 minus 4 root 2 minus, this becomes 5 root 2. Because the square root of 25 is 5 and root 2 remains inside. So now I say, I have negative 4 root 2, negative 5 root 2. So the final answer becomes 6 root 5 minus 9 root 2. And that would be your final answer for that question. Notice the first step is to reduce this radical. Once you have it reduced, then we can combine like terms. We could combine these two terms and end up with negative 9 root 2. Make sense? Okay, so again, when adding or subtracting radicals, they must have the same radicand. They must have the same thing inside the radical symbol in order for you to combine. Okay, let's look at another case. Okay, so if I gave you 4 square root of 3 minus 2 what is that equal to? Well, take a look. The radicand is the same. What is inside the radical is 3 and 3. However, this is square root, and this is cube root. Apple, orange. 2 different radicals, so they cannot be combined. So the answer is unchanged, cannot be simplified. Okay? So again, in order for you to be able to combine 2 radicals, they must be the same root and they must have the same radicand. They must have the same thing inside the radical symbol. So same thing inside as well as same root. Either the same square root or the same cube root or the same fifth root, whatever the root is, they have to be identical in order for you to combine them. Okay? You might get an example like this. if you were given a question like this, what I recommend is, in order to get this done, you simplify each radical. You simplify each radical. You reduce each radical and then see what can be combined. So you do each piece separately. So this is actually 5 times 25. And then 5 times 5. So we see something going on right here. What about this? This is 3 times 25, and then 5 times 5. Interesting. And this is 2 times 6, 2 times 3. So what do we end up with? We end up with the square root of 5 squared. We need a pair and a single times 5 minus 2 times, this is a pair, times 3 plus 5 times, this is a pair, is 2 squared times 3. Now we're ready to simplify. 5 comes out and 5 stays in. So this is 5 root 5. 5 comes out, 3 stays in. When 5 comes out, you have 5 times 2. So it is minus 10 root 3. How did we get the 10? When the 5 comes out, it's 5 times 2 gives us 10. Root 3, because the 3 is single, so it stays inside. Plus 2 squared, 2 comes out. 2 times 5 is 10. Root 3 stays inside. So plus 10 root 3. And then we go to the last step. What do we notice? Negative 10 root 3, positive 10 root 3. Wow! These two cancel each other. So your final answer is 5 root 5. So we started with this, and our final answer is this. There it is. What was the process? We reduce each radical to the lowest form, and then we see what could be combined, and that's how we got our final answer. All right? So let's move along nicely. So we did addition and we did multiplication of radicals. Let's try, addition and subtraction. Let's try multiplication. If I ask you, what is the square root of 20 times the square root of 5? What's that equal to? You're multiplying two radicals. What's it equal to? Well, I often tell my students that if it's the same root and you're multiplying, you can put them under the same umbrella. I used Rihanna as an example. I said, okay, put them under the same umbrella. It's the same square root, so it's actually 20 times 5. So it's equal to the square root of 20 times 5 equal to the square root of 100 equal to 10. So the final answer is 10. Let's see if we could prove that it's 10 using a different method. Okay, so this is 2 times 10. This is 2 times 5. So therefore, this expression here is square root of 2 squared times 5 times the square root of 5. Again, 2 squared times 5 times the square root of 5. So it's equal to 2 comes out. So it's 2 root 5 times root 5. So it's the square root of 5 times the square root of 5. So that's going to be 5. It's actually 2 times 5, which is equal to 10. Okay? Same answer as before. So the easy way to do it is to, since it's square root and you're multiplying, you put it under the same umbrella. So the rule is square root of x times the square root of y is equal to the square root of x, y. That is the rule. And I can use a very good example for you. I can use a very good example to show that it works. Let's use perfect squares and see if they match up. If I ask you for the square root of 4 times the square root of 16. Well, the square root of 4 is 2. Square root of 16 is 4. 8. If we use the method of putting them under the same radical, we're saying that that's equal to the square root of 4 times 16 equal to the square root of 64. What is the square root of 64? The answer is 8. And we see the two answers are identical. Just in case you think I'm tricking you, let's try another one. Let's try another one. If I ask you for the square root of 100 times the square root of 9. We know this is equal to the square root of 100 is 10. The square root of 9 is 3. That's equal to 30. If we put them together under the same radical, we end up with the square root of 900. And you know, and I know, that 30 times 30 is equal to 900. So the square root of 900 is 30. Same result. It works. Okay? It works. Now, what I would like to do is, I would like to share something with you about radicals, because I did this for you. I said to you, the square root of 5 times the square root of 5 is equal to 5. And you must be wondering, how come? Well, if you put them together, it's the square root of 25. Put them under this, well, and maybe, let me not skip step. Put them under the same radical, it's 5 times 5. So it's the square root of 25, which of course gives you 5. But I'm going to show you another way to be convinced that the square root of x times the square root of x is just x. I'm going to show you another way. The square root of 100 can be written as a power. And the power that it is, this is square root, it can be written as 100 to the power a half. So square root is to the power half. If you put this in your calculator, you will end up with the same answer as 10. But the way that you enter it in your calculator, you type in 100 carat and parentheses 1 divided by 2. I promise you, if you enter this in your calculator, you will get 10. Similarly, if I enter the cube root of 27, it's the same as 27 to the power 1/3. So cube root is 1/3, square root is 1/2, fifth root is 1/5, seventh root is 1/7, fourth root is 1/4. Get it? 10th root, 1/10. I guarantee if you do 27 carat 1 divided by 3, you will get 3. And in this case, you will get 10. Guaranteed. So when I said the square root of 5 times the square root of 5, then you could write that as 5 to the half times 5 to the half. And in a previous session, we discussed that when you multiply like terms, you add the exponents. So a half plus a half is uno, is 1, is equal to 5 to the power 1, which of course is the same as 5. So I'm just showing you, just in case you did not like the multiplication, where we put them under the same radical, square root of 25. I'm showing you using the exponent a half. Half plus a half is 1. And that's where you get the same thing with 5. Okay? Good. Now I am ready to solve radical equations. Okay, solve. Square root of x plus 3 equal to 7. We need to find x. So we need to get x by itself. We need to isolate the x. So what do I need to do? How would I accomplish that? Well, I must get rid of the positive 3, and then I also must get rid of the radical. So I have two things to do. Get rid of the positive 3, get rid of the radical, boom, x is by itself. So how do I get rid of this positive 3? I subtract 3 from both sides. So now we end up with square root of x is equal to 4. How do I get rid of the square root? You do the inverse. So the inverse of square root is square. In other words, when you square both sides, remember, square root of x times square root of x is equal to the square root of x squared. Square root is what times itself gives you this. So we know that the answer is just x. Or you could say this is x to the half times x to the half, which is equal to x to the power 1, which we just write as just plain x. The square root of x squared is x. 4 squared is 16. Let's check to see if it works. Square root of 16 is 4. 4 plus 3 is 7. Let's try another one. Okay, just a little bit more involved. Your goal is to get x by itself. So we need to isolate the x, and the way you do that is you get rid of everything so that x is left by itself on the left-hand side. What would you do first? In a previous session, I explained to you that the way you solve these equations, whatever is further away must be gotten rid of first. So you can't get rid of this 2 until later. This is the closest thing to the x. So that has to come last. That has been the last thing that has to be gotten rid of. So the -4 is the one that's further away. So the -4 goes first. How do I get rid of -4? I do the inverse. We add 4. So now we add 4. This becomes 0. So now we have the square root of 2x plus 6 equals to 22. Okay? So what do we do now? We need to get rid of the square root. In order to get inside, we have to get rid of the shell that's outside. So we need to get rid of the square root. How do you get rid of the square root? By squaring both sides. Didn't realize that my numbers were so big, so I'm going to have to do a little math to the side. Oh, we got it, 484. So when I square this side, the radical disappears. Because when you multiply a square root by itself, the square root goes away. So the left becomes, when I square this, and I square that, I end up with 2x plus 6 equal to 484. 22 squared is 484. Now we subtract 6. 2x equal to 478. And now we get rid of the 2 by dividing both sides by 2. We end up with x equals to 239. There it is. How cool is that? Let's try another one. What we had okay, so this 2 is multiplying this radical. So it's 2 times the radical, 2 times the cube root of 4x minus 5 minus 7 equal 1. Notice the minus 7 is not inside the radical, it's outside the radical. So we need to get x by itself. We need to go through the process. We need to get rid of this -7. We do that by doing the up, we add 7 to both sides. So now we end up with 2 times the cube root of 4x minus 5 is equal to 8. Again, we're trying to get to x, but we have to get rid of all the stuff on the outside before we can get on the inside. So now we need to get rid of the 2. How do we get rid of the 2? We divide. You're multiplying by 2, so we divide by 2. So now we have the cube root of 4x minus 5 equal to 4. Now we come to the big step. How do we get rid of the cube root? You see, the cube root is the inverse of cubing. So you have x cubed. To get rid of the cube, we do the cube root. If you have cube root, to get rid of the cube root, you cube. You do the opposite, you do the inverse. So what do you do here? You cube, you raise each side to the power 3. This cancels this. So now we're left with 4x minus 5 equal to 4 cubed, which is 64. And then from here, you add 5 to both sides and then divide by 4. Add 5 to that, we get 69. Divide by 4, we end up with x equal to 69 divided by 4. See, step by step, sequentially processing, systematically tackling it, one step after another, after another, after another. Okay, let me get a piece of paper. I'll do one more example. So far, each of the questions that we have done, each question only had one radical. Now I'm going to change it a little and give you 2 radicals and see what we do. Wow, that's pretty ugly. So how do you tackle this? Well, I'm glad you asked. My suggestion is 2 kings cannot reign in the same country. So you give each king its own country where possible. So in this case, both kings are on the left side. So if you split them up, let one king stay on the left and one king go to the right, then there can be peace. And then you can proceed. So I would get rid of this radical by getting it over to the right side. By what? Adding this expression to both sides. So now we end up with 5 plus 2x equal to 3 square root of x minus 4. So now we have a radical on the left, a radical on the right. And now you square both sides. So now we square, now we square. Be very careful when you do that side over there. This side is easy because the square cancels the square root and all we're left with is 5 plus 2x. Now on this side, you're squaring everything on the inside. So it's going to be 3 squared is 9. And then when you square this, the radical disappears. So you end up with 9 times x minus 4. And now what do you have? You have a linear equation. So you went from a radical equation to a linear equation, and then that it becomes very easy. So we distribute, we end up with 5 plus 2x equal to 9x minus 36. So we could add 36 to both sides. We end up with 41 plus 2x equal to 9x. Subtract 2x from both sides. We end up with 41 equal to 7x. And then at this stage, divide both sides by 7, and we end up with x equal to 41 divided by 7. So let's go over what we did. We isolated the radicals, put one on the left, one on the right, and then we square both sides carefully because we don't want to miss out on the fact that the 3 outside the radical must become 3 squared, which gives you 9. This is a piece that will hurt some people who are not paying attention. The square is squaring everything inside. So 3 squared is 9. Square root of x minus 4 times the square root of x minus 4 is just x minus 4. That is a little pothole that you have to watch out for, otherwise you'll drop in it and cause some damage. But if you're careful, you will avoid the pothole. And then from here, it becomes very easy linear equation. And that's it for now, folks. I would love to be able to do one question, not today, maybe the next session, in which it's not as easy as this, but you end up with something else that's not a radical, and you end up with something looking more complicated. I might do that next time we meet. Okay? Thank you so much for joining us for another session of Learning Together, sponsored by the Russies Brosis Foundation. I do hope that this was interesting for you. It was challenging, I hope, and you're also intrigued to join us for another session, whether it's for English or for math. For now, we close and I ask you to enjoy the rest of your day.